So let's start with some administrative stuff. Is everybody doing okay with code grade and like submissions for the homework so far? I know first homework is due Thursday, and then the second homework I think is due on Monday or Tuesday. I think it was the 6th. I'll have to double check. Just wanted to make sure there's not any serious issues with that because I know it does give people some trouble. I guess in any case, if you are having issues with it, just send me an email. I think that's about everything administrative. Let's go ahead and. Oh, it's a Sunday for assignment too? I think that's right. I think that's what I imported it as. I was told it was a bit shorter, so I think we're going to try to stick with that unless everybody's really stuck on it. Okay, cool. I guess on that note, let's finish up what we were talking about last time, and then we'll get into some new material here. So I think what we ended on, and we kind of had to go through quickly. Oh, another question. If we do get stuck, what's the best way to reach you? Preferably email. I am on Discord, but I occasionally go offline just because I also have class most of the day, and sometimes I don't get a chance to read it. Email is usually the best way, so I would definitely say check out the syllabus, and it should be on there. But Discord's okay too, especially for like quick questions. Right, but I guess the last class we ended on this, both in the context that's there and the word this. It's going to be very confusing when we talk about this for the sake of this class because it's really hard to get the sentence out correctly. So the last class we ended just barely on this thing, this. And the reason we said we were using it in this context is the fact that we wanted to resolve some ambiguity in our naming schemes. So remember that we said, similar to what you learned in 135, whenever you declare an integer, or sorry, not an integer, declare a variable with some name, if there's another variable with that same name in the enclosing scope, then it overshadows it, right? So if I had a global variable called skew, and then I go and create a local to this function, in this case this constructor, also called skew, then the one that this function will use between these curly braces is always the most recent one, in this case the function parameter, and not the global. And so we said the same thing applies to classes. The ways that that worked right is that we had a member, in this case called skew, and then quantity and name and price, which were for like shopping items that we were doing. And then we said that, well, if I wanted to name these parameters the same thing, which is totally allowed, if I want to name those skew and quantity and name and price the exact same things, then it would completely overshadow the ones that exist in the class, and we would only get the function parameter ones. And so we had an issue where if I wanted to be able to access the member ones, the ones that exist inside the class, then I couldn't anymore. And that might be a serious issue because, well, if you're inside a class, it's pretty important to be able to use the things that the class has. So the way we said we were able to resolve that ambiguity is the name skew, for example, here just meant the skew like the parameter, like we're used to. It's the most recent declared one. But if we want to gain access to an instance variable, one that belongs to the specific class, then we can use this and then the little arrow, which is used with pointers, which we'll get into maybe this week, maybe next week. And so this kind of resolved that for us. Right, so the same thing goes here. So let's explain a little bit more in detail what this means. Right, so we said, just as a refresher from past two class, we said that something like a class or a struct is a blueprint. So let's just say I'm going to make a class called example, just call it EX for the sake of simplicity. And it's just going to contain, let's just say, an integer called n, and let's just say a string called str. I'm just going to throw them on the same line for the sake of space. And then if I was to go ... and go to some code, a function or main or whatever, and declare a variable of type EX. So this was the blueprint, and then if I ever go into a actual piece of code in a function and declare a variable of that same class name, or whatever data type it is, then it's going to go and make an instance or an object. So let's just say I create example E0, let's say. I create the first one, and then I go and create the second one. And better yet, let's just also, let's pretend I wrote a constructor, partly for the sake of remembering what a constructor is, but also just to make my life easier. Let's just say I wrote a constructor that exists somewhere in here. Let's just pretend I wrote it. And it takes the integer and then the string and then initializes them the way it should. So it does this, let's just say. Then what each of these lines do, what we said, whenever we declare a variable, it goes and instantiates something. So whereas this was a description of something, then an instantiation is when we actually go to make whatever that thing is. This one is E0. It's like its own self-contained bubble, and it has an integer called n, and it's 4 here, and then it has a string called str, which is hello. And then this one here has its own integer that's completely distinct from E0. So E1 has its own n, and it's that, and it has its own world, or own string, which is this one. Right, so we said they have like their own self-contained things, and they might also have their own functions, right? So I might have something called like print or whatever that belongs to this class, and I can call that and whatever. So when we actually write code that goes into a class, right? We've been writing these functions that belong to a class. So I might do that, for example, here, just on top of an integer and a string. I might declare that there's a void returning function called print that just prints these two fields for this class. And whenever I have an object I call print, it has access to, I suppose I should put parentheses, it has access to everything that belongs to that instance, assuming it's non-static, right? We mentioned static stuff a little bit last class. So here, if I was to call like e0.print, it's going to go and print, and it's going to know only the things in this bubble, all the things that belong to E0, and if I called it print on E0, and only the things that belong to E1 on that. And so if I want to actually access or know what the thing is that I'm in, every class object, so it has to be non-static, will have a reference to themselves called this. So if I was to call e0.print, for example, so I just go further down in my code and call e0.print, what a function does, if you remember from 135, is it just jumps over to wherever the code is. So jump up to here, assuming that we wrote the print function, and it would execute all that code. But once I get into that code block itself, wherever I do anything inside of that, I'm going to have a variable that represents whoever it is that called that function. So if I call e0.print and it goes and says, okay, I'm going to go run that code wherever it is. Let's pretend this is where the print code is, somewhere here. And then whenever I use this, it's referring to whoever made this function happen, whoever called it. So it's referring to E0. And so that's how we can tell just whoever called a function, or whoever this code belongs to. And so that's helpful if we just ever want to know more information, or we have to resolve an ambiguity or something like that. Really, the only two practical use cases for it that you'll encounter commonly are the first one that we did last class, which was just resolving name ambiguities. If you reuse the same name and you don't want it to have an issue with your member variables, then you should use it there. And then the other common example that I would think of is if you have a function that takes a class as a parameter and you need to call it. So for instance, if I had a just a global variable, global function called like void I don't know, add to queue or something weird like that, or add to vector, let's just say, and it took an example, it would probably be a pointer, which we haven't got to yet, but that's okay. Then if I wanted to, add whatever this is to the vector, let's say that's what the function does, it just takes the parameter e and it adds it to some vector, then if I wanted to call it from some sort of function belonging to the example class, then I might call it like add to vector, and then since it takes a example object to add to that vector, then I might say, okay, we'll add this to it. And what this does is it just says, okay, the object I'm adding to this one is this. The equivalent to writing this in main would be add to vector e0. So these two in our example do exactly the same thing. This write in main would just add the e0 object to a vector, assuming that's what the code does, and the other one would add that same e0. It's just the fact that once we're in that function, the way we identify it as being itself is this keyword. Are there any questions on that? I know it can be a little bit hard to wrap your head around at first, but does this make sense? We'll hopefully see some more examples as we get into pointers. Okay, fair enough. If anybody has any questions, just stop me at any point. Okay, so I think that's okay for this. And I think I just wanted to finish up on talking about some C++ stuff first, and then we'll get into a new topic. I don't think there was anything else pertaining to that shopping example that we had to go over. Let's actually just look through this really quick. Now we'll do it in the new project. So I'm going to close this. I have a new project already. I was just going to use it to code up some stuff. But we'll use it for an example. So I wanted to go over... It's not really in the syllabus, and it's not in the syllabus for 135, but I think they're useful to know. So I wanted to talk about preprocessor directives and namespaces. And you've been using them both a lot, I'm sure, but probably don't really explain them in detail in 135 because it's a little bit technical, but that's okay. Let's talk a little bit about that. So we've been putting, like a pound sign and then include IOStream or pound include vector or whatever library that you want. And we haven't really explained what that means. I mean, it's probably obvious what it does, right? When you write the word include, it goes and includes the code that exists there. But there's actually something special about these pounds in terms of how they're processed versus how your actual code is processed. So whenever you see this pound, it means that it's a preprocessor directive, at least in something like C, C++, and C#. That's what that means. In other languages, it has to do with a comment. But you'll see this in languages that are able to be compiled, which C++ we do, right? We use the G++ compiler, at least on Sally. That's what you usually do. And what these do is they address things via the compiler rather than when the program runs. So I think I mentioned just kind of offhand in one of these lectures that the include keyword, when you use that preprocessor directive, what it physically goes and does is it grabs that IOStream library, which is installed somewhere on your computer or whatever computer you're using, and it just grabs all the code and then copy and paste it in here. And so the compiler resolves any of these things before you ever run, and then so when you actually generate the executable, it has like no idea what kind of preprocessor directives there were. So this is one major one that we've been using a lot. It's just copy and paste code. Let's go over another example really quick. I'm planning on using some of these in a future assignment that I'm writing, so part of why I mention it. Not that you're going to have to use them, but it's nice to know. And so another common one is called define. And define has two ways that you can use it in C and C++. And the first one is you can use it to define like a Boolean, I guess you could say. So here I'm just going to say define, let's just say example. I like to do all caps for these. And these need to go before any actual code is one stipulation to these. What this does actually is it determines what code gets compiled. So here if I wrote cout, this code is getting executed, and line, and then so I do need namespace standard. Let's go ahead and write that. What I'm going to do here is there's another preprocessor directive that goes along with define, and it's called if or ifdef. I'm going to use ifdef here. There's also ifndef, which stands for if not defined, so you can always use that as well. But I'm going to do ifdef. Visual Studio autocompletes debug, but I'm just going to put the example one that we wrote. So example here, and then it left a comment, but the way you have to denote these rather than using the curly braces is with another preprocessor directive, so I put an end if here. So any code between this will get executed only if define, if example is defined. So here I'm just going to write cout example is defined. And then I'm going to run this, and what we should see that happens is it's going to print both these statements. Give it a second here. Takes a while to compile it the first time. And I might actually just copy and paste this over to another file so that we have it for an example. Let me open that really quick. But right, I run it, and it just says both those things that we put in the code. So it says the code is getting executed, example is defined. Okay, perfect. What I can do then is if I don't define example, you'll see Visual Studio automatically grays it out, but what this does is it actually just makes this code disappear. So if I run this code again, we're actually just going to see that the first one prints, and then because I've no longer defined example, it's just going to not do that code. So this code is getting executed. So it's almost exactly like a normal if statement. The only difference is that it's a preprocessor directive. And you might wonder, why is that important? Or why would you not just use a normal if? Like, why not just put like a Boolean called example that's global and kind of set that or whatever? And you totally could, but there's something nice about this. Does anybody know, based off of what I said earlier, what that might be? Why might you use this over a normal if? And this is probably a lot of people's first experience with this, so totally understandable if not familiar with it. So the reason you would use this over a normal if is that, like other preprocessor directives, it handles it at compilation time. So remember that, that's not the window. There it is. Remember that something like C++, right, is that it has a source file, which is just like your .cpp. It's something that you've written and can kind of understand, and then you throw it into a compiler, and then a compiler generates an executable, right? Or something, but for our case, it's an executable. And so this is like runnable, right? The computer can go and run this. But this is not runnable, it's just something that we can read. And so with a compiler, the purpose of it is to go and take something that's readable and make it readable by the computer, right? Able to be executed. The reason you would use an if as a preprocessor directive is that the compiler handles it. So if def gets, and if not def, gets handled here, which is a one-time thing when you compile your program and generates the executable. And so any of that code that exists just gets deleted from your source file by the if def. So if it's not defined, the compiler will go physically look at it and be like, okay, well, I guess I'm just going to throw out this code. Whereas if I do the normal if that we're used to from CS135, then that happens here because it's just an instruction that we've been telling the compiler to do. It says, well, go check this thing and do something if it's true, and branch to this other place if it's false. So the main difference is where it happens. If you do it at compile time, then consider that you never have to do it when you run it, because that's all an executable is, right? It actually runs the program, whereas the compiler just generates the executable. So you get some efficiency if you do it this way versus an actual if, so that's why I mention it. You'll see a lot of people do preprocessor directives because they're very nice for just cutting out a lot of stuff. You'll see that Visual Studio, the reason it gave me that debug at first is because it has a built-in preprocessor directive. So when you're actually writing programs, it's nice to keep in your mind that you could either define your own preprocessor directive called like debug, or that Visual Studio will handle it for you. And you can use that to put in things very quickly that just debug your code. Like if you want to make sure that your functions are written correctly and you just want to print things out, you can define that and put whatever code is for printing debug in an if-def. So that's nice, I think. I would say that that's pretty helpful just in general if you're writing like big things. Do you have to use define at the top of code? Yes, you do. Preprocessor directives generally need to be written at the top. I think C++ requires it be at the top as well. The only exception to these is usually if-def and region, which maybe I'll show region at some point as well. That's more of just a Visual Studio thing, I think. But yeah, most languages require you to put it at the very top before you write any code. I don't think you're allowed to put it later, but I could be wrong. I know C# doesn't let you do it, so I figure C++ is the same. The other thing you can do with define, if you really wanted to, is you can use it to define a constant. So I could just say like pi and define it as 3.14. 1 second. And this is, again, a little bit different than just declaring a constant normally, because if you declare a constant normally, it just, goes and makes a variable and then does it at runtime. And if you do it this way, it actually just goes anywhere in your code. So if I just said, let's just say float radius equals 7.0, and then I wanted to calculate the area of a circle with this radius, then I might say that the area is equal to pi r squared, so it's pi times radius times radius. The advantage of doing this, if you can spell, is that it physically goes and again just copy and paste stuff. So this goes and fills in the 3.14 wherever it sees the pi, and then just deletes this line of code. Well, it's not really a line of code, it's a preprocessor directive. And so it gets handled at compile time, and you can actually boost your efficiency a little bit if you do it. So just a nice thing to know. Not required, but you'll see people write it, and I think in some of the upper division courses, some people will use it and just never explain it. So I know I got confused when I took operating systems, and I saw a bunch of these, and I didn't really know what they meant. I think there was one other one I was going to mention. I'm forgetting. I suppose I'll come back to it if I remember. I think. I said region. I guess we can show that one. Region's one that only works in Visual Studio. Does it not work in C++? I could have swore it did. I suppose it doesn't. Never mind. I could have swore I used it last semester. Put that back. And region, if you happen to use a language that uses it, just lets you do this little collapsible thingy. Oh well, I don't think it works. I don't remember the other one I was going to mention, so let's just move on to namespaces really quick. And so you've been using namespace standard a lot. A namespace is just something that holds variables. It's very similar to how a class works. The only difference is that it's static and it can't be instantiated. And so, at least in C++, that's the way it works. So I think somebody had mentioned it last class, brought up some namespaces, but really it's just like a way to group variables together if you kind of want to turn them on or off, I guess, would be a way to think about it. So when I go and create a namespace, which the way you should do it is namespace and then whatever the name of the namespace is. So if I went and defined a namespace standard somewhere, then it has like variables that you can use. So it has something called ostream cout and istream cin. and stuff like that. So it's just a collection of variables. In the same way, I could do that in my code here if I really wanted to. So I could say namespace, my namespace or something like that. And then it should be this syntax, I think. Yep. And so I could create a variable called, let's just say, integer x and make it belong to that. And so here, if I was to go and use this, I would say x, and it's going to say, well, that doesn't exist. That's undefined. But if I say my namespace x, or let's do it the way we're used to first. If I was to say like using namespace, my namespace, then suddenly it knows what x means. So whenever you say this using namespace stuff, it just like gives you access to a space of names, just like a collection of variables or classes or functions. It's kind of a way to limit code if you just don't want to use it, or if you want to group it together even further. I know we've been using namespaces a lot. I just feel like it would be a good idea to explain it. Last thing to mention on that is, because this is a compiler error that I think people get a lot, is it will give you this with the 2 colons. It'll say like standard namespace not defined or something like that. You might get an error a lot of the time that says standard : cout is not defined. And that would be why, is if you don't put the using namespace, another way you can look into that namespace is you just give the name of the namespace and then 2 colons. So that's another alternative. I'm going to put both of them here just so that we have it for the example, my namespace. So whenever you do the using namespace standard, it just goes and says, okay, give me all the access to all these variables without me having to type anything. And that's all that means. Any questions on those? I know these might be a little bit boring. It's just some conveniences in C++. All right, so let's move on to new material then. I'm just going to go ahead and cut all of this. I'm going to move it to a different file. Since I'm not going to run this or anything, I'm just going to go save it so I can upload it to Canvas later. Example program, so we'll just say this is a preprocessor example. Okay, cool. And then let's actually try to do something. We've worked a little bit with classes now, and they're a bit limited in what we can do currently, or at least with what we know. So let's add a little bit onto that. Let's say I was writing some kind of program where I had, let's just say, animals, for an example. And I knew I wanted a class for, let's just say, cats and dogs and that kind of stuff. So I might say, you know, there's a cat class, so I need to define a class with a cat. And I might give it a string name. And then, I don't know, an integer age. And, I don't know, we'll just say like int whiskers. And then we'll say void meow. So I can have functions that belong to specifically that class, and then we'll say that's okay. And then let's say I have another one, let's just say class dog. And that one also has a name. And it has an age. And then we'll just say void bark. And I could keep doing these with more animals, right? I could write a bird, and it would probably have a name and an age and maybe some other stuff. Void chirp, that kind of stuff. One other thing to notice is that between these classes, there's some similarities. So they both have this, and then they have their own special things, right? This has only these functions, and then this one only has this function here. And so they share some things, but there's also some differences. And if we expect something to consistently have the same sort of things over and over again, then it might be convenient to be able to reuse those. So what I'm going to do is a separate example here, where instead of creating a cat and a dog class separately, where they share these things, let's create a different kind of class and then borrow these things that they share so that we don't have to rewrite them. So I'm going to do a class called animal. And that one will have string name, let's just say. And int age. Now, if I want to be able to borrow these things, the way I can do that is with something called inheritance. Let's put this off to the side. Inheritance is when we take things and repurpose them in a new ADT, a class or a struct. So let's say I do a cat again. Then the way I inherit is with these colons, and then I give the name of the class. In C++, you also have to put a modifier before it, public, private, or protected. So I'm going to put public here, and then animal. What the modifier does, and this is like a C++ thing, a lot of other languages don't do this, but you need to put a modifier before this. If you don't, it again assumes it's private by default because it's a class, and it will actually just overwrite any of your variables and make them all private even though they weren't, which is kind of annoying in my opinion. And sometimes I forget that this is a thing, and I get compiler errors, so that's why I feel like I should mention it. You need to put public in order for it to keep all of your same stuff. What this does actually is, let's just say this one was public and this one was private. What it does is it looks at each of the old modifiers when you do this new modifier, and it picks between the old one and whatever is the most lax out of that one and the one that you specified. So when I write public and public, or sorry, whichever one's most strict. So it picks the most strict. So when this goes to copy over the name, it's going to pick whichever is most strict between public and public, which they're the same, so it just picks public. So name is going to be inherited public here. When it goes to look at this one, which is private for the age, and then public for my modifier on the class, it picks the one which is more strict, which is private, because it's more restrictive in how you can access it. And so it goes and it says, well, age is going to be private. So if you ever do public as your modifier, it's just going to keep everything the same because that's the least strict thing that you can possibly do. If you don't put anything, so if I just did that, it's going to assume it's private, and that means that it's going to go and compare the name here between public and the private that's implied. And it's going to say, okay, well, I'm going to make the name private now. And in my opinion, that's really annoying. And it's kind of just a C++ thing. But just when in doubt, put a public before your inheritance. In C++ at least. Other languages don't make you do this. Anyways, if we wanted to make this look the way that the other one looked, it had the age and the name, and then we wanted to add the meow and the whiskers. So all I have to write now, because we said that this just borrows things, is an integer for the whiskers and then the void meow. And so this go ahead and just borrows from the class it inherits from its parent, which is the animal. So void meow. And this keeps us both from rewriting code a lot of the time, as well as it allows us to group certain things together, because we can be certain that things of a given class are going to all have the same thing. So because I would go and finish writing this and write class dog also inherits from animal, it would also go ahead and copy over any of those fields, the string name and the int age. And so we can be absolutely 100% sure that both a cat and a dog are going to have a name and an age, and that gives us some flexibility because we know that they're both guaranteed to share that in common. And so if I wrote a function where I need to print the name of something, I could make it just on an animal basis and then give it cats and dogs. And we'll see an example of that in a little bit. Let's go ahead and just draw this off to the side here in a more realistic kind of drawing. So the way that you'll see these a lot is with these class hierarchy diagram. So I'm going to create one here called animal. And this is the parent, is what I usually call it, but I think in C++ the terminology is base class. And then we can inherit from it. So this one had an int age and a string name. And whenever I do inheritance, then anything above it gets borrowed. So I'm going to say that this is inherits. The arrow's going down. And so a cat is going to inherit from that, and then it has the whiskers and the void meow. And then we'll do another one that inherits, and then a dog inherits from that, and it might just have the void bark. Okay, and so these things like follow from that. And so another way to think about this and think about whether your class relationship makes sense is called an is-a relationship. So you see this a lot when people are writing class diagrams or class hierarchy diagrams like this, is they'll use the term is-a, which I think makes sense just from our point of view. So a cat is an animal, a dog is also an animal, and an animal is not necessarily a cat, and an animal is not necessarily a dog, right? So this is like that whole, a square is a rectangle, but a rectangle is not a square, right? Kind of logic. You can do an is-a relationship to figure out what kind of class this is. So a cat is an animal and a dog is an animal, and implies that a cat is a derived class and a animal is a base class. So I didn't put the word here, but this is called a derived, or child is what I usually say. Child or derived class. Again, I think the C++ one is the derived part. But it's kind of like that, right? So if I was to draw a class hierarchy diagram for squares and rectangles, then a rectangle might be here, and then a square inherits from that, because a square is a specific kind of rectangle. Does that make sense so far? Yeah, okay, cool. So this is the general idea behind inheritance. There's one other type of relationship that we'll say, I don't really ever see anybody bring it up, but there's another one called has a, and it just means that it's a member of it. So animal has a age, a cat has a age. It just means that they have access to that specific variable. So that's just kind of a thing you can do with that. Let's do this as a programming example really quick, just so we can have it. And then if we have time, we'll go into some new material. So I think I had a few ideas. We'll just keep it kind of simple. Let's say I want to write a program that handles different users, and let's say it's for the school. So you have access to users that are going to be instructors, and then users that are going to be students. So we'll write a very simple setup here. We'll just put namespace standard, and then int main. And then, again, for practice, let's go ahead and separate our files. So I'm going to go ahead and create a header file. And we'll just call it user.h. And then I will create a corresponding source. I don't think I did this last class, but I'll mention it. You can have multiple source files. So here I'm going to do this. I'll try to compile it. Remind me before we leave to show you how you would compile this on Google Server with G++. Corresponding CPP. So you can have multiple CPPs. I think I mentioned this before, but we didn't actually do it. I don't even think I spelled it right. User CPP.cpp. Let me fix that. So it's common to have a header file which has the definitions and then a CPP file which has actual code in it is kind of the common practice. And then you just kind of include what you need. So here, let's just write a user class and then all the other stuff that we're going to inherit from it. So maybe what we'd expect a user to have is we might expect them to have an email address that identifies them, and I need to include string. Include string using namespace standard. Oh, right. One other thing I did want to talk about, because it plagued me when I was an undergrad, is if you do this include, because we mentioned preprocessor directives earlier, I'm going to need to include this user.h. Just consider what I said earlier. It does literally copy and paste the code whenever you write this, and because of that, it is going to do it in the exact order, copy and paste all the code that you wrote the includes in. So if you're writing multiple header files and you include them, make sure you do it in the right order, because you might end up being like me and include them in the wrong order one day and then the right order the next day and wonder why your code's not working, because C++ does put them in order. So just be aware of that. I almost failed operating systems because I didn't know that. And just, I don't want anybody else to do that. So just keep that in mind. I digress. So we might say a user has an email, and we might say that they have like a first name and a last name. Let's just throw these all on the same line. So first, last, and then maybe a password as well, which you should never keep in a class like this. That's a bad idea, but we're going to do it anyways. And then we might have like a long for their ID. Let's just say a ulong for that. I guess in C++ it's unsigned long. Okay, unsigned long. This just means it has no negative. Maybe we just use this to look up user information in our database, just because it's easier if you do it with a number. And that's probably good. We might also have like a void sign in function or something like that attempts to sign in the user to a database or whatever. So these are things that we would expect for both a instructor and a student to have if we were to write this example, right, where there's an instructor and a student. And so it's nice, again, for us not to have to rewrite any of this stuff. So I might go ahead and make an instructor, and then I might go ahead and make a student class, and we want these to inherit, so I'm going to put public and then user. Oops. There we go. And then I should do the same thing on this one. So then a instructor is a user and a student is also a user, but they're going to have their own separate things. So I might, for a student, now on top of their ID, I might also, let's just say for the sake of UNLV, I might have an entry for a student. I think instructors do have them too, but let's just pretend that they don't. And then, you know, an instructor might have, let's just say, an array of students. You know, that's totally fine. They might have an array of student called students. Or, you know, maybe there's some sort of course. Let's say class course, which has a student array, student. Let's just do it like this. I know it's bad to use that magic numbers, but I'm just going to throw 100 in there. Right, so you might have an instructor have an array of courses. So they might say courses, and then have 10, let's just say max is what they're allowed to have. Right, so these end up having different fields, and they'll all share the ability to have an email and a first name and a last name and all that kind of stuff. And so you can allow these to also have like their own distinct constructors as well this way. So let's really quick, let's write two constructors. So let's just write kind of a default constructor. Well, let's not write a default constructor, but let's write like a really simple constructor for user. So I'm going to make a public constructor, and I'm just going to call it, let's just say user, because that's what a constructor needs to look like. And then we'll just have it fill in all this stuff. So let's say string email FLP. I'm just going to be lazy here and do it this way. String F, string L for last name, string P for password, and then long, unsigned long for the ID, which we'll just call I. In fact, this is what I usually do, is I'll set a default parameter for these. I don't know if they covered this in 135, but if you ever want a parameter to just get a value if somebody doesn't plug it into their function, you can actually do that just by putting like equal and then whatever it is. It does have to be a compile time constant, which means that it has to either be like a literal like this, where I just literally write a number, or a string or whatever kind of data type it is, or it has to be something else that is already marked as a constant, or a preprocessor directive or something like that. Just in case you haven't learned that from 135. Anyways, yeah, so this will fill in ID equals 0 if I just never type it in. Let's use this to initialize everything. And okay, I think we're good. A nice thing about inheritance with constructors is that you can actually also reuse constructors and functions that have been written and not have to rewrite those. So here I could, write an entire constructor that takes these 5 things and then rewrite all this code, and that's fine. It would be okay, I guess. But what I can also actually do is write a constructor that specifically calls this one. So I'm going to take this same argument list really quick, but I'm also going to throw in a int here for the nc. I'm just going to do it in lowercase. And I could just copy and paste all this, right? And say, well, let's make the student's email E and the first name F, and copy all of that over. That'd be totally fine, but I'm not going to do it that way. What I'm going to do instead is, oh, I didn't finish typing everything. Did I delete the instructor somehow? I'm just going to go back to wherever I was. Oh no. My code is ruined. Alright, good enough. This is pretty close to where we are. So I could create a student constructor that takes pretty much all the same arguments. I'm going to throw it in the extra nc there, because if we notice here, right, that's what the student has extra. And I could just have it execute all of this code without having to rewrite it. And so what we were saying was, and let me do public, is we could just copy and paste this and put it down there, and that'd be fine. It would work. But what we can also do is, and you'll see it even gives me an error that says no default constructor, is we can have it call that constructor of the user class. And so the way you do that in C++ is you actually write whatever the name of the class is you want to call the constructor of, assuming it's a base class of the current one, which user is a base class of student, and we can feed it all of the arguments. So E, F, L, P, and I. And so what this will do is whenever you construct a student, it's actually going to go and call the user constructor first with all these arguments. It's going to go up there and plug all those in with whatever E, F, L, P, and I were for the student, and then it will come back here and execute the actual student, constructor. So I'm going to do nc equals nc, and we'll show this in the debugger. So I'm going to put down a breakpoint really quick right there. If you're using Visual Studio, I guess this is a nice thing to know. If you press F9 on your keyboard or go to debug, set breakpoint, toggle breakpoint, then you'll see a little red dot. Whenever you run it with the debugger, it will actually take your code and pause running right here, and you can look at all your variables and stuff, and it's really helpful. So if you're using Visual Studio, totally do this. It's great. It makes debugging your programs super easy. if you get used to it. I didn't start using this until I was in grad school, and let me tell you, it would have made things way easier as an undergrad using this. And it's only in Visual Studio. VS Code, I think it's a little bit weird. And you can do it via command line in Linux, although you have to like specifically set up some things. GDB is what you usually use for that. But yeah, it's really easy here. Just put a little red circle and it's good. But I'm going to do that here just so we can see the execution. And what we establish here is that this is going to use that constructor first. Now what C++ does, and the reason it gave me a compiler error earlier, is if you don't actually do this, it goes and calls the default constructor for the base class, regardless of whether you want it to or not, which, again, I think is a little tedious, but C++ does it. So just be aware, if you're experiencing some weird side effects, it may be that it's calling the base class constructor, default constructor, even though you didn't tell it to. It just goes and does it. I think that about handles all of this stuff. Let's get into writing our actual code here. I'm not going to have a CPP file, I guess, and don't really need to write anything in there. I can write the sign-in function. In fact, I should probably do that really quick, just for the sake of, whatever, not having a compiler error. So void sign in, we would need to include user.h, and then we would write void user sign in, and then I'm just going to have it see out the password and username for the time being. I think it was email is what I called it. Oh, my errors are going the wrong way. I'm not going to use this, I just feel like it's a good idea to write. Okay, so now let's say I go to main and I want to go and create all these things, then I can do that. So I could say like student s, and no default constructor, right? So I had to give it something. I can call the student constructor with a email, first name, last name. So let's just say my email. I'm not going to actually format this correctly just because that's a lot of writing. Their name is HW. Their password is pass1234. Their NSHI is 23, and their ID is, let's just say, 2. And so I could make a student. I could make a teacher now. Actually, I think the teacher, or I call it instructor, is going to have an issue. Instructor I. And that has no constructor. Actually, yes it does. So one nice thing about this, let's actually write it out this way. Email to me. Another pass, I think password was the next one, and then 1. Const car int. Did I not call that correctly? I think, if I remember correctly, in C++, if you don't write a constructor, it just doesn't use one for a derived class. Which again is a little weird in my opinion. But let's just copy and paste this into the instructor for now. So I'm going to do a public constructor. And I'm just going to have it do the exact same thing as the user. Instructor. By just calling the user class. If you wanted to do that, you can always just put this here and then put empty braces and just not write any code. Why is it giving an error? Default constructor, of course, cannot be referenced. Is it deleted? And the course doesn't have a constructor either. I'm going to have to write all this stuff. So I'd need to give a default student constructor. Student, first off. So one other thing I think we addressed in the last... Yeah, I'd have to write one for user as well. See, this is a little bit annoying about C++, is that if you don't implement these, it'll just make you implement blank ones. Oh, I see question. So if you have to write a separate constructor, what exactly is getting inherited by the children objects? Yeah, at least the methods or functions and the... What's it called? The functions and the members are, and you also still get the ability to call any of the base class constructors that you've written. So again, it's a little bit annoying in C++ that it forces you to write some anyways. In C# and Java, it doesn't. You can just it'll automatically assume that you mean the inherited or like the base class versions when you write that in C# and Java. From my experience in C++, I don't think there's a way around that. It makes you write them if you absolutely require it, just because of the way that certain things are done. But you do at least still get the advantage of being able to call any base class constructor. So it doesn't seem like super complicated, right? Because I'm just setting these things right now. So it wouldn't be that bad for me to just copy and paste this here. But you might do something that's like complicated code that does like a sort on the constructor, or like accesses a server or whatever. And in that case, I think it's nice to not have to rewrite all the code. You can just call the base class constructor. So it is still a little bit tedious, but yeah, there's at least some advantage to it. But so fair question. Yeah, last class we mentioned if you declare an array, it actually just calls the array with the base class constructor. So if it doesn't exist, it gets angry at you. And so just be aware. That's why I'm putting this completely useless constructor here. And it's giving me a green line because it's saying that nothing happens in it. But I kind of need that to exist. So just kind of an unfortunate thing about C++. I do need to write a constructor for this, though. It might also get angry at you if the default constructor is not accessible. It's not like public. So keep that in mind, too. In this one, I'm just going to do nothing as well. I think this about covers everything. Oh, one other thing, actually. I didn't encounter this error, but I would have if I did copy and paste the code. So I was just thinking about it. I would have also gotten an error if I just copy and pasted this code here straight into the student. Does anybody know why I would have gotten an error? At least I should. It's something that's kind of new, so it might not be obvious, but let's kind of walk through it. What's the modifier on these things? Is it public or private? Private. You guys are right. It's private. So if you don't write a modifier in a class, it's private by default. So these are private. What did private mean again? Where is it accessible? I don't see any responses, but that's okay. Only with, okay, or you guys got it. Only within the object, only within the class. Kind of close, just be careful with your terminology. Object is an instance. Yeah, so only in the class is right. And the reason I say not an object is because static counts too, and that's not an object. But you guys are on the right track. So private variables are only accessible within the class they belong to. And so this, even though it inherits from it, is not the same class. The student is not the same class as the user. So if it tries to access the email or the first name or the last name or the password or the ID directly, you're going to get a inaccessibility error because those are private and you're not allowed to access it. And so one way you can get around that is there's a third modifier. There's 3 modifiers in C++, public, protected, and private. public means, like we said before, just accessible to everybody. Private means that it's only accessible to that class. Protected means it's accessible to that class as well as anything that inherits from it. So here we can say now these are accessible by the base class. So if I wanted to, let's just say, for instance, write email equals e, then that would not generate an error, but just to verify that what I said was right, if I didn't accidentally delete this curly brace, if I got rid of that protected and then saved, you'll see it says, oh, there's an inaccessibility error because it's private. Yeah, so let's just make that protected for the sake of it. I think protected is generally good if you know you're going to be writing things with inheritance. I usually just write it by default. Very rarely do I actually use private, but we bring it up anyways, just because it's nice to have. Cool. I think that about covers everything with these here. We can go back to main here. So now this student would construct that student, and this instructor would construct an instructor called I with all of these things here. And the only difference we said between these is that the student has like an N sheet, which is this 23, and then the instructor has an I. Now I could also construct just a normal user. We'll learn how to stop ourselves from being able to do this later, because I would argue that a user is not specific enough that you should use it here, because nobody's just a user in our system, right? They have to be an instructor or a student, and so you should kind of limit this, but it's totally an option with what we have now. And I could set that equal to this, and that's fine. Just change it up a little bit. Cool, so we can call all that stuff. Now let's run through two last things really quick. So first things first, I wanted to run through in the debugger just to show how things jump around and also to get an idea of how the debugger works. So I'm going to hit F9. When I run this, you'll see that it's going to stop partway through running. The C++ debugger is a little bit strange. It sometimes goes into like libraries, and it's hard to tell what's going on, but we'll try to follow along here. So it stopped at this. You can see the little arrow. Stopped at line 7. I'm going to hit this little arrow at the top to just walk by one line at a time through the code. You'll also see at the bottom, the text is probably kind of small, but you'll see that I actually have access to whatever these variables are, which is fantastic. So I have like S and U, which are all just uninitialized right now. They're just kind of garbage, but you can access and look at like all of the stuff that belongs to a variable in the debugger, and this is just like super good for not having to put a billion debug statements. You can just kind of look in the debugger and see what your variables are. So we'll see these update as we go along here. I can either hit continue, which is just going to go to the next breakpoints. So the next time it executes line by line and hits one of those red circles, it'll stop. Or I can hit this little step into button, and it will just go line by line. So I went from line 7 to line 8, and then it's going to go from line 8 to the constructor probably. Hopefully. It's going to go into the string constructor, which is called basic string here. So this is a library function. I'm just going to keep stepping through. You'll see it's going into all this stuff that looks really technical and crazy, and that's okay. We'll just kind of keep going. You can also hit Shift F11 or step over, I think it is. Step out, and that'll leave all this code. So I'm actually just going to do that really quick, and it's going to keep going and doing all these string constructors really quick because I have all these strings. So it's going into the code that corresponds to strings. But you know, we go through all that, all the technical stuff. It ends up here at the student constructor, which is what we called when we created something. And so the reason we went here is we wanted to see, well, how exactly does this constructor work? Well, it comes here to the top of the constructor. When we go into the next line, hopefully it doesn't go into a library, but it does. We're going to go ahead and see that it's going to call the string constructors again, unfortunately. And once it's done with all that mess, it ends up at the user constructor. Right, so we saw the little arrow there, and now it's going to keep calling the string constructors, because that's what it does. And it finally goes into the user constructor, so we see the little yellow arrow. But the point being is that it executes, whenever you do a constructor, it executes the base class constructor, whatever you call after this before it executes the body of the constructor, all this stuff between the curly braces. So this goes up here and it's going to do the email and the first and the last, and it has to go and figure out what equal means and all that. But we can, go through all that. It says enshi, and then it returns back to main after it calls all the string deconstructors, which we'll get into at some point. Okay. The main reason I did that was just to show you what order it executes in, but also to kind of give you an idea of the debugger. We saw that now we're on like line 9, which came after the declaration of S. If I was to go and look at S in the debugger now, you'll see that it has all of my variables set. So you'll see, and specifically, I guess the C++ debugger shows you the base class. It says, well, the user component of this has an email, and it's set to my email, and the first is set to H, and the last is set to W, and all that stuff. So if you're ever like really stuck writing your programs and you're on Windows, I super recommend Visual Studio. It's really easy to set this up. You literally just hit the little green button at the top and put the red circle with the F9 key, and it will just show you all that. Okay, so we see the memory locations of variables as well. Good question. If it's a pointer, it will show it to you by default, since a pointer is a memory location. I don't think it does by default. There might be a setting that lets you do it. If you really need to see the memory location of those, there's another way that we'll learn how to do that in the future. But generally for debugging, it's not going to show you those because you don't usually need them. Unless it is something that specifically uses memory locations, like a pointer or an array or something. So actually you'll see here, it gives some memory addresses, just because these things aren't filled. So like I has a memory address for courses because that's an array. Things that involve memory addresses it will show you by default, but just normal stuff it doesn't, because you don't necessarily need to know that for like your debugging process, if that makes sense. But does that all make sense? Okay, cool. Yeah, and actually, thank you for bringing that up, because the C++ debugger will show you memory addresses. Usually I would just say ignore them. They're not super important, and they're probably going to be kind of random. If you do it with like C# and Java, it won't show you those to you, which is fine, in my opinion. Okay, anyways, that's just an overview of the debugger and kind of how the constructor works. Now, one last thing let's get into here is being able to use these inherited variables in a different way. So we said here that an instructor is a user and a student is a user. And so we're actually able to do some things with that that aren't going to be super useful for what we've done so far, but once we get into pointers and virtual stuff, then you'll see that this is actually one of the most useful things that you can do. So let's say I create a user variable called u, and I set it equal to an instructor. So remember, we can call a constructor for a new object without having to do a variable declaration, just by giving the name of the class in C++, and then whatever arguments after it. So let's say I fill that in with all those strings and stuff, and it worked. I could potentially also do this. So I guess I'll say in advance, both of these things are allowed. One of these things requires something extra, and the other one does not. So let's say I just say instructor I, and I set it equal to a new user ... fill in all that stuff, whatever it is. So these are going to do two different things. One's going to make an instructor and set it equal to a user variable, and the other one is going to set a user variable. It's going to make one and set it equal to an instructor variable. Object. It's going to make a user object and set it equal to an instructor variable. Instructor object and set it equal to a user variable. And we said earlier that our class hierarchy looks something like this. So out of these two, let's just say this is a line 0 and line 1. Which one of these do you think makes more sense to be able to do and why. One of these is going to generate a compiler error by default, and the other one's not. So which one do you think would work? Okay, so I see one answer. Any other guesses? Okay, fair enough. I at least got one answer. And just to clarify, do you mean 0 is going to generate an error, or 0 is going to be the one that works? I think you mean it works, right? Yeah, and you're right. 0 is the one that's going to work. And it's exactly like you said. And just for people who can't see the chat, if you're looking at the recording, what Colton said here was, because an instructor is a user, but a user isn't necessarily an instructor, which is exactly right. This is an is-a relationship. And so an instructor is a user, but a user is not necessarily an instructor. And so this here is what we would call downcasting, even though it's coercion. I'm just going to call it downcasting, and this one's called upcasting. And it has to do with this class hierarchy direction. So this one's called downcasting because it is, well, I guess the is-a relationship is downwards and the other one's upwards. So we're making this go. I could have swore that was. I'm sorry. I'm writing that the wrong way. This is downcasting. That's upcasting. I realize the arrows kind of messed that up. Downcasting is when we create something that's lower, that's down, and then. No, I was right originally. I take that back. Whatever the final type is the thing that you cast to. So this is casting upwards on the class hierarchy tree. This one's casting downwards. I was right originally. I'm sorry. Ending myself. So yeah. Upcasting is allowed by default. Downcasting is not. Yeah. And the reason is to elaborate on what was said in the chat is because an instructor has, let's just say in this example, an email and a first name and a last name, then we can expect when we create the instructor that it's going to have all of the things necessary for a user to work, because we're guaranteed that any instructor for sure has all the stuff that a user has. So it has a name, a first name, last name, email, all that stuff. But if I try to set a user to an instructor, then that's not necessarily going to work, because even though they share all the same stuff, specifically the stuff that a user has, a user is not guaranteed to have all of the stuff that an instructor has. So it doesn't necessarily have that array of courses that we wrote, right? A user might even be a student if we were to do things under specific situations. So you're not allowed to do this unless you specifically ask for it. So this one generates a compiler error. One way I could fix this up is by writing it this way. So remember, the way we cast in C++ is with this. We just write the type in parentheses and then whatever it is that we want. So if I then wrote the constructor for the user that had all that stuff in it, then this would work because it would create the user and then it would cast it to an instructor. So it is still allowed because there is some utility to being able to go down words like that, even if it doesn't have all the requirements that is necessary. So this is technically allowed, but it's not allowed by default. You specifically have to cast it, otherwise it just won't let it happen. And so this is explicitly downcasting when I physically write the cast there. I remember that cast, all that does is just change the type of something. Now, something to be aware of because of this is we might actually still encounter the error that we mentioned earlier, where it doesn't have all of the correct stuff or just isn't the right type. Maybe it's like a student is actually in that user variable and we try to downcast it and there might be an error. And the compiler can't know this in advance, so it's not going to give you an error if you write it this way, but that error can still happen if you write your code wrong. And so you can possibly have your program crash. It's called a typecast error if you do it this way and you just do it wrong. So be aware of that. But very important is that we can do this upcasting stuff where we can go from anything lower on the tree and just kind of cast it to an up thing. So I can set an instructor equal to a user variable. I could set a cat equal to an animal variable. I could set a dog equal to an animal variable. And it becomes useful in that we can reuse or keep some consistency in the functions that they have. And we'll see that a lot when we get into virtual functions. Anyways, I think that is the end of class. In the next class, we'll start talking about pointers, I think. I'll stay a little bit after if anybody has any questions on the assignment. I have office hours again tomorrow. And then just remember that the first assignment's due Thursday, and then the other one's due this weekend. The second one.